Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 25 to 29 of the January 2018 Algebra 2 New York Regents exam. Alright, let's take a look at question 25. It reads, Elizabeth tried to find the product of 2 plus 4i and 3 minus I, and her work is shown below. So we have Elizabeth's work right here. Question: identify the error in the process shown and determine the correct product of 2 plus 4i and 3 minus I. Alright, before we start, let's go ahead and do a real quick review on the formula for reducing powers of I. Okay? Reducing or simplifying powers of I. So let's do a real quick review on the formulas. On simplifying powers of I. Okay, so the rule basically is as follows. If the power of I is greater than 1, it can or should be simplified. Okay, so how do you go ahead to simplify the powers of I that are greater than 1? You can use the following pattern that we're going to generate right now. So let's say you have I to the first power. I to the first power is just I. It needs no simplification. If you raise I to the second power, this is basically squaring, you're squaring the square root of -1. By definition, I is the square root of -1. So when you square that, the square takes out the square root, and you end up with -1. I to the third power is the product of I and I squared. If you multiply the reduced form, you have -1 times I, which is -I. I to the fourth power can simply be determined by squaring I squared, which is -1. -1 squared is +1. Okay? Now what if you have I to the fifth power? Guess what? The pattern starts over at I to the first power. So I to the first power is the same thing as I to the fifth. I to the sixth power, you just continue with the pattern, is the same thing as I squared. I to the seventh power is the same thing as I to the third, and I to the eighth power is the same thing as I to the fourth. So the pattern continues over and over again. So basically, if you continue, the general pattern is as follows. So for any power of I that can be written in the form I to the 4n plus 1 basically reduces to I. Okay? If you have I to the 4n plus 2, it reduces to -1. And then I to the 4n plus 3 reduces to -I. And then lastly, I to the 4n reduces to 1. Just like I to the 4, I to the 8th, I to the 12, it just goes on and on like that. Okay, so with that in mind, let's go ahead and take a look at Elizabeth's work and see where she made the mistake. Okay, so what I'm going to do is I'm just going to solve the problem and see the point where our results differ. So we have 2 plus 4i times 3 minus I. So we're just going to multiply. This is still we're foiling. We're going to multiply the real part of the first factor with the real part of the second and the imaginary part. And then we are going to take the imaginary part of the first factor and distribute it to the real and imaginary parts of the second factor. Alrighty, so 2 times 3 is 6. 2 times -I is -2i. Positive 4i times 3 is positive 12i. Positive 4i times -I plus times minus 4i squared. Let's compare with what Elizabeth has. It's the same, so this line is correct. Let's go on with our simplification. We just combine like terms. We have 6. -2 plus 10. -2 plus 12 is positive 10i minus 4i squared. Let's see what Elizabeth has. 6 plus 10 minus 5 squared. That's correct. Good. Moving along. Now, remember, if you have powers of I that are greater than 1, you have to reduce it. Okay? So we have 6 plus 10I minus 4. This I has a power that's greater than 1, so we're going to use this rule right here. I squared reduces to negative 1, so it's 4 times negative 1. Alright, let's see what we have. Elizabeth messed up. The error Elizabeth made is that she simplified I square incorrectly. I square is not 1. I square is negative 1. Okay? Alright, so let's go ahead and finish up the problem because the question asks us not just to identify but determine the correct product. So let's finish this problem off. We'll have 6 plus 10I. Now this minus and this minus multiply to give us plus 4, unlike minus that she has here. And then to finish things off, we'll just combine the real parts. 6 plus 4, which is 10. 10 plus 10I. And that's the final result. Alright, so we're going to go ahead and specify what error Elizabeth made and state what the correct answer is as indicated in the question. Okay, so Elizabeth made an error in the third step where she incorrectly simplifies I square as positive 1 instead of negative 1. Alright, the correct answer is what? The correct answer is 10 plus 10I. Okay? Alright, so that's that with question 25. Alright, let's take a look at question 26. It reads, a runner is using a 9-week training app to prepare for a fun run. The table below represents the amount of program completed, A, and the distance covered in a session, D, in miles. Based on these data, write an exponential regression equation rounded to the nearest thousandth to model the distance the runner is able to complete in a session as she continues through the 9-week program. Okay, so to generate an exponential regression equation, we're going to be making use of our calculators. What we'll do is we're going to enter this information into the list in the calculator and then use the exponential regression function to generate the A and B values that we're going to input into our exponential regression equation. Alright, so we're going to start off by entering row A into the first list and row D into the second list, and then we'll calculate what the exponential regression function is using the information that we entered. Okay, so we're going to be accessing the list feature and the TI-84. So just by pressing second function statistics, we'll get the list. Or I'll just press statistics and we can get access to the list. So if you press stats or statistics, under edit, just press enter. So you have list 1, 2, 3, 4, it goes on and on. We're just going to use two lists here. Okay, L1 represent A and L2 represent D. So let's go ahead and enter L1. First entry is 4 over 9. Enter. Notice that it's converted into its decimal form. That's not a problem. That's okay. And then second entry is 5 over 9. Next entry is 6 over 9. Next entry is 8 over 9. And then the last entry is 1. Okay? So row A is entered into list 1. We're going to proceed to enter row D into list 2. Okay, so we have 2, enter, 2, enter, 2.25, enter, 3, enter, and then 3.25, enter. Okay, so we have everything entered. Alright, so what we're going to do now is we're going to calculate the exponential regression using this data. To do that, we'll press statistics again, go to the calculate option by scrolling to the right, and then we're going to look for exponential regression. So we have quadratic regression, cubic, quartic regression, linear regression, and logarithmic, and then exponential regression. That's what we want. So press enter. Exponential regression is entered into the home screen. Press enter, and then it generates the exponential regression equation and the a and b values. Okay, so if you notice, it also gives us where to input a and b into our exponential regression equation. It tells us that it's of the form y equals ab to the x, and then the a and b values are specified. We're rounding to the nearest thousandth or to 3 decimal places, and remember it starts with tenth, hundredth, and then thousandth. Okay, so let's go ahead and write this down. A is going to be approximately 1.223 to the nearest thousandth or 3 decimal places, and B is going to be 2.652 to the nearest thousandth. Okay, so our final answer is going to be y equals A, which is 1.223 times B, 2.652 raised to the x power. And this represents the exponential regression model for this data that we have here. Alright, let's take a look at question 27. It reads, a formula for work problems involving 2 people is shown below. So we have the formula right here and the values of T1, T2, and TB. Fred and Barney are carpenters who build the same model desk. It takes Fred 8 hours to build the desk, while it takes Barney only 6 hours to build the desk. Question: write an equation that can be used to find the time it would take both carpenters working together to build the desk. Alright, so let's go ahead and assign variables to Fred, Barney, and their combined work rate. Okay, so let T1 be the time it takes Barney to complete the work. Actually, let's let T1 be Fred's time. Okay, so let Fred's time be T1. Okay, and it takes Fred, when working alone, it takes Fred 8 hours. Okay, and then we're gonna let Barney's time Barney's time be T2, which is how long does it take Barney when working alone? If Barney's working alone, it takes him 6 hours. So we're to write the equation, it would an equation that it will take to find the time when both of them are working together. So what variable are we going to use for Fred and Barney's combined time? We're going to use T sub B, okay, because T sub B is for the combined time working together. Okay, so combined time be T sub B, which is what we don't know what it is. Alright, let's go ahead and write down the equation that can be used to find the combined time. So equation to find combined time is going to be, if we look at the formula, we have 1 over T1 plus 1 over T2 equals 1 over T combined. So 1 over T1 in this case is going to be 1 over 8 plus 1 over t2 will be 1 over 6 equals 1 over t sub b. So this is the equation that will help us to find the combined time t sub b. Okay, now the B part, it states determine to the nearest tenth of an hour how long it would take Fred and Barney working together to build the desk. So we're going to basically solve this equation for t sub b. Okay, so we have 1 over 8 plus 1 over 6 equals 1 over t sub b. Now what I'm going to do first is combine these two fractions on the left into one fraction, cross multiply and divide by the coefficient of t sub b. And that should be the answer. Alright, so let's go ahead and combine these two fractions. To do that, we have to find the LCD of 8 and 6. The smallest number that 8 and 6 go into evenly is 24. Okay, so we need to change the denominators to 24. We need two equivalent fractions where the denominator is 24. So times 8 by 3, top and bottom. And then we're going to times 6 by 4, top and bottom. And then we're going to have 3 over 24 plus 4 over 24 equals 1 over t sub b. Let's go ahead and combine the fractions on the left. Since your denominators are the same, you add a numerator, you have 7 over 24 equals 1 over t sub b. Now we're going to proceed to cross multiply. Bottom top, bottom top. We'll have 7 times t sub b is equal to 24. To get t sub b isolated, combine time, we divide both sides by 7. The exact result for the combined time t sub b is 24 over 7. Okay, 24 over 7, the unit is hours, 24 over 7 hours. But the problem asks for the result to be expressed to the nearest tenth of an hour, or just one decimal place. So to do that, we're going to evaluate this quotient using our calculators. Okay, so let's clear this. 24 divided by 7 is 3.42857, but I want to round it to one decimal place. So it's going to be 3.4 hours as our final result. Alright, let's take a look at question 28. We have to factor the expression x squared plus 3xy plus 3x to the third plus y. Now when you're given four terms, you want to think about factoring by grouping. Okay, you want to partition and then factor by grouping. Now sometimes you might have to rearrange terms in order for factoring by grouping to occur. Okay, if we try to factor by grouping with the way it's presented, we might run into some complications. Alright, let me show it to you on the side right here. So without rearranging terms, we just want to factor just with the way it's presented. We'll have x squared plus 3xy plus 3x cubed plus y. Break it down the center. From the first two, we could take out x, and then we have x plus 3y. And then over here, you can't take out anything, so you just take out 1, and they have 3x cubed plus y. And if you look at the quantities in the parentheses, they're different, so you can't factor by grouping with this original format. But if it doesn't work, that doesn't automatically mean that you cannot factor by grouping. You might have to rearrange terms. Now what if we interchange the middle terms? What if we have x squared plus 3x to the third and then plus y plus 3xy. Okay, so I'm grouping this 3xy, I'm moving it with the y, and then 3x to the third with x squared. Let's see what happens here. So over here I can factor out x squared. So let's factor that out. X squared, we're left with 1 plus 3x. And then on the next two, let me put my partition down. On the next two, I can factor out y. If I factor out y, I'll have 1 plus 3x. This is nice because you notice the quantities in the parentheses are identical. Just by moving terms around, you see what we have been able to accomplish? So since these two quantities are identical, we can factor it out, 1 plus 3x. And then we have x squared plus y on the outside. Those two are grouped into their own parentheses. So the final answer for this problem is 1 plus 3x times x squared plus y. Okay? So that's that. Okay, let's take a look at question 29. It says, researchers in a local area found that the population of rabbits with an initial population of 20 grew continuously at a rate of 5% per month. The fox population had an initial value of 30 and grew continuously at a rate of 3% per month. Question, find to the nearest tenth of a month how long it takes these populations to be equal. Okay, so what we're to do here is basically generate two exponential or population growth models and determine the time value when they are going to be equal. Alright, so let's go ahead and write down the formula for continuous exponential growth. So formula, continuous exponential growth. The formula for continuous exponential growth is given by y equals p e to the rt. Another way we can write down this formula, we can also write it as a final amount equals initial amount, population in this context, e to the rt. Okay, so what we're going to do is we're going to formulate two models, okay, one for rabbits and the other for fox. So let's start with rabbit first. So what's the model for rabbit? The model for rabbit is, well, we'll start with initial amount, initial population, which is a sub 0 is 20, and then the growth rate r is 5%, which is 0.05 in decimal form. Alright, so that could give us a model. The model is going to be final amount equals initial amount, e to the r 0.05 t. Alright, so that's for rabbit. Now let's go ahead and generate the model for fox. Initial population of the fox is 30. The growth rate r is 3%. Of course, we want to write this in decimal form, 0.03. So the model for fox is a equals initial amount e to the r 0.03 t. Okay, so what we're going to do now is we want to find when the populations are equal. So we can call this a sub r for amount of rabbit and a sub f for amount of fox. So the population of rabbit and fox are equal when what? They're equal when amount of rabbit is equal to the amount of fox. Basically when 20 e to the 0.05 t is equal to 30 e to the 0.03 t. There are two ways you can solve this problem. You can graph these two functions and find the point of intersection that will be the answer. Or you can just use algebra to solve this exponential equation. Alright, so I'm going to go ahead and use algebra to solve this. So what we're going to do is, let's go ahead and divide both sides by 30. I want the numbers on the right side, and then I want the e's on the numbers on the left, and then e's on the right. So I'll start by dividing both sides by 30. 30's divide out here, and then this 0 and this 0 divide out. So you have 2 e to the 0.05t equals e to the 0.03t. Now you can proceed to divide both sides by e to the 0.05t. On the left side, e to the 0.05t divide out. So we are going to have 2. Oh, there's a 3 there. Let's not forget that. 2 over 3 equals, now when you're dividing exponents with the same base, all you do is you subtract the powers, right? So you're going to have e to the 0.03t minus 0.05t. And then we're now going to have 2 over 3 equals e to the negative 0.02t. To get t by itself, we'll take the natural logarithm of both sides of the equation. Equals the natural logarithm of e to the negative 0.02t. Now what happens on the right side? Well, that's why we took the natural logarithm, is that the ln and the e's cancel each other out. Okay? Alright, so we are going to now have negative 0.02t equals, now we're going to evaluate the natural logarithm of 2 over 3. We're going to do that with our calculators. So the natural logarithm of 2 over 3 is negative 0.4055, so equals negative 0.4055. And then the last step, we'll just divide both sides by negative 0.02 to get t isolated, negative 0.02. And the time when the population will be the same will be given by the quotient. So we have this divided by negative 0.02. And we get 20.2732. So t is equal to 20.2732. Okay, let's see how many decimal places. To the nearest tenth, so 1 decimal place. Alright, so if we round this to the nearest tenth, t is going to be approximately 20.3, and the unit for time is months. Okay. Alright, so let's go ahead and contextualize our answer within the scenario that we're dealing with. It will take 20.3 months for the population of rabbits and foxes to be the same. Alright, so that's that. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions or comments, just post it in the comment section below, and we will be more than glad to respond. For more support resources, go ahead and visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.